Good day everyone. Today we are discussing Unit 5 Thermal Energy Storage Applications. The topic that we are going to discuss is solar energy storage, passive heating and cooling, or greenhouse heating. Before going into the topic, let's discuss the advantages of heat storage in building. First and the foremost point is there is a reduction in peak power for heating or cooling of a building because of this heat storage. Because effectively, the heat storage reduces the amount of heat coming in, or the cooling effect coming into the building during winter, for instance, and there is a time delay or lag for the energy transfer, which in effect keeps the building at moderate temperatures, thereby reducing the power required for cooling down the building or heating up the building during the according to the outside conditions. Similarly, there is a possibility of peak power shifting. That is, this is effectively used by companies as of now. That is, we have something called tariffs. At particular times, like for instance in houses and all, during evening we have the maximum energy consumptions, and during midnight or early morning hours we have the least energy consumptions. The government, according to that, have set tariffs, how much energy we consume during the peak hours will be having a higher tariff than that having the lower tariff. So possibly if heat energy storage system can be incorporated into a building, we can shift to some extent the peak load to the off tariff hours, low tariff hours, so that we can gain financially from it. Similarly, the third one is shifting temperatures from peak to non-working hours, the same as the above function. And D is improvement in indoor environment, meaning we will get better or moderate internal environment rather than very hot temperatures inside the room or cold temperatures inside the room. The thermal energy storage takes away a small amount of heat or gives out the heat depending upon the conditions, and it will keep a moderate environment, indoor environment inside the house passively. Similarly, effective utilization of passive heating and cooling loads. So these are the 5 advantages of using heat storage system in a building. Moving on, going to the topic solar passive heating or same heating, solar passive cooling. So we have an abundant source of energy from the sun that can be, if a small portion of it can be harnessed, then it will be like more than enough for the whole world to survive, or for humanity to survive. Similarly, if you use these techniques or passive heating and cooling techniques on buildings, we can generate the required amount of energy from the sun itself, as well as generate electrical power if you use concentrated systems like solar power plant and all. Going on, first is solar heating systems for homes. Okay, so solar heating systems or passive heating based on the architecture, that is the sun and that is designing the building according to the availability of sun, water, wind and other factors. We can keep the building either cold during winter, summer time, and warm during winter time. So based on design of the building as well as the materials incorporated in the building, we can make something we call as a energy efficient house, which will be helping us in keeping the buildings warm during winters and cool during hot summers. So a passive solar home or a building is for heating purpose. If I'm saying, it will be mostly using something called south facing glass windows, which will enable the heat to come inside, and it will be entrapping the heat inside, so that during winter seasons the buildings will be slightly warmer than outside. Similarly, these buildings also use the sun spaces. Sun spaces or attached greenhouse, both are same. So in the sense, these are like glassed panes, which allows the direct sunlight into the building and heats up the building structures which acts as that is blackened structures which acts as absorbers, so that the building will be warmer than outside. Similarly, you have the tiles, bricks, and other materials, building materials. We usually make it thick so that it absorbs the heat during the daytime and releases it during night time. So these all structures in effect helps in heating of the houses. Similarly, you have a solar cooling system for houses. One of the primary thing is ventilators that we use to keep the building cool. That is holes on top of the rooms that is called as vents or air vents, uh, which removes the hot air that is resting on the top of the houses to outside, and cold air will come in from the windows and occupies that space. Similarly, you have thick walls or stone muds which acts as insulators in traditional houses, which prevent uh, heat coming into the building and keep it cooler during hot summer. Similarly, you have doors and windows are kept small so that direct light does not come in. And another important thing is sunshade. This sunshade keeps the direct heat from coming into the house, while at the same time it provides natural lighting into the building. That is, it will allow the lights to come in, that is the reflected light, while preventing the direct hot sunlight to enter into the building. Similarly, you have high roofs in traditional bungalows where the hot rises to the top, and small ventilators on top which will be allowing the hot air to leave the room. Another kind of system that exists in old houses or even in modern houses is cross ventilation, where two windows will be kept in such an alignment such that if you open both the windows, air will come in from one direction and it will leave through the other window, keeping the whole house cool. So this is the national average home energy cost. It is around 44% of the energy that we utilize is used for heating and cooling the building, and another high amount like 33% is for lighting, cooking, and utilizing other appliances, and 9% for refrigeration, and 14% for water heating. So this is the average. You can see that almost 77% of the energy can be replaced, not 77, more than that can be replaced by solar systems. Even water heating, you can use passive solar heating systems, and most of the energy requirement can be removed or replaced by natural or passive, by utilizing passive architectures in buildings. So moving on, this is like how much energy is conventionally lost by a house. So you can see that most of the energy are lost through the side walls, windows, doors, and other structures. That is around 38% and 70% through the wall frame of the thing, wall frame to outside, to the radiation, or convection, or connection. All these three modes of heat transfer is most commonly occurring, which will enable the losses as well as heat transfer into the building as well as out of the building is done by these three modes of heat transfer. So most of the energy is lost from the walls and windows and doors. Moving on, we have types of heating systems, that is one is active heating system and the passive heating system. So in active heating systems, we use water pumps or blowers to pump air or water, which acts as a fluid to transfer heat. So while passive heating systems, air moves naturally due to the density difference or due to the convection currents or due to gravity. By using principles like thermocycle principles in a passive solar water heating system. So we have two modes, we have active mode as well as the passive mode. Moving on, the Center for Renewable Energy Resources estimates that around 75% of the energy bill can be reduced by adding a construction cost of 5 to 10%. That is, if your house cost 50 lakhs, by giving another 5 or 10 lakhs, like 60 lakhs, we can include all these additional features into the building that makes the building a low cost or low energy efficient buildings.